Hi, in this video, I will be showing you a 22.5 watt fast charging power bank module that can charge almost any type of mobile phone. We will also test this circuit to see how much maximum power it can actually deliver. This power bank module is built on a compact size PCB and requires only a single lithium polymer battery with simple connections to operate. It features two USB ports, one Type-C port, one Lightning port, and a micro Type-B port. A small push button is available to power up the module, and it automatically turns off when idle. A great feature for saving power. The module also includes a protection IC that monitors and safeguards the circuit. Its main chip is located next to a display that shows the battery status and percentage. Each port has its own dedicated power transistor, ensuring that every port receives sufficient power for proper delivery. For testing purposes, I have prepared this battery pack by connecting two lithium polymer batteries in parallel. Let's first measure the output voltage of the battery using a multimeter. It shows almost 4 volts, indicating that the batteries are nearly fully charged. Now let's quickly solder the battery wires to the module terminals so we can start the testing process. The module can be charged using its bidirectional Type-C port, which also supports fast charging of the power bank itself. A red LED indicates charging status. To test the maximum output power, I will use this USB trigger module along with my load tester. Let's connect the load tester to the trigger module. First, we will test the module for its peak output power at 12 volts. As I gradually increase the load current, you can see the output voltage slowly dropping. At 1 ampere load, we get nearly 12 watts of output power. At 1.5 ampere load, we get 17.7 watts at 11.85 volts. Beyond 1.7 ampere, the voltage starts dropping more quickly. At 1.9 ampere load, we reach 20.4 watts at 10.7 volts. At 2.1 ampere load, the module's protection circuit activates and shuts down the output to prevent damage. Let's reset the module and replug the load tester to start the test process again. At 2.0 ampere load, the voltage drops to 7.8 volts and the power falls to 15.8 watts, confirming that this module is best used up to 1.9 ampere at 12 volts, around 20.4 watts peak power. Testing at 9 volts output. At 0.7 ampere load, power reaches 6.3 watts. At 1 ampere load, the voltage remains steady at 9 volts. At 1.5 ampere load, power reaches 13.3 watts with a small 0.1 voltage drop. At 2.1 ampere load, we get 18.6 watts. At 2.3 ampere load, we see 20.2 watts with a 0.2 voltage drop. At 2.4 ampere load, the power peaks at 21.2 watts before the voltage and power start dropping significantly. Now testing at 5 volts output. At 1 ampere load, power equals 5 watts. At 1.5 ampere load, power equals 7.4 watts. At 2 ampere load, power equals 9.8 watts. At 2.5 ampere load, power equals 12 watts with a slight voltage drop of 0.2 volts. At 3.1 ampere load, peak power reaches 14.6 watts, after which both voltage and power drop due to overloading. That's all for today. If you enjoyed this tutorial, don't forget to like, share, and subscribe. Let's keep the spirit of engineering alive.